In this lesson, we're going to talk about rules of exponents. So we've seen exponents before, right? We know that if I have 3 squared, that means 3 times 3. If I have 4 to the third, that means 4 times 4 times 4. Okay? You guys know the difference between an exponent and a base. But just to cover, the base is the number that's being raised to a power. The exponent is the actual power. So again, in this case, 5 to the third or 5 cubed, this is my exponent or my power. And 5 ends up being the base. We can see a bunch of different examples of that. We've seen this a million times. Anytime you raise a number to a power, again, the base is the number that's being raised to the power, which is the exponent. So now let's talk about some of these rules, okay? You already understand what these exponents tell you to do. If I have 5 to the third, it means 5 times 5 times 5. If I have 3 squared, it means 3 times 3. If I have 6 to the power of 7, I'm multiplying 6 by itself 7 times, right? So let's look at the product rule. Product rule says in order to multiply when two bases are the same, write the base and add the exponents. What in the world does that mean? Let's say, for example, you have 2 to the third times 2 to the fourth. Okay? It says to multiply when two bases are the same. Notice the two bases are the same. We've got bases of 2. If I'm multiplying 2 cubed times 2 to the fourth, my answer is going to be the base. You're going to keep the base, and you're going to add the exponents, meaning you're going to take 3 plus 4. So your answer becomes 2 to the 7th. Now, why is that? Well, let's think about it. 2 to the third. 2 to the third means 2 times 2 times 2. And 2 to the fourth means 2 times 2 times 2 times 2. And if I'm multiplying them together, I now have 1, 2, 3, 4, 5, 6, 7 2's, which is just 2 to the 7th power. Okay? This works in any case. Same thing with variables. If I have x to the 5th times x squared, this just gives me x, because remember, my bases are the same, and then 5 plus 2, which gives me x to the 7th. That's it. Anytime you multiply two bases that are the same, that have exponents, you just keep the base and you add the exponents. That's the product rule. What I want you to understand is this does not mean that you can add them together. Okay, you're not going to add the bases. This doesn't become 4 to the 7th, it becomes 2 to the 7th. And I showed you why right here. Again, we broke down 2 to the third, it gave me 2 times 2 times 2, and 2 to the fourth, which gives me 2 times 2 times 2 times 2. And when I put them together, there's 7 2's, so it's 2 to the 7th. Same thing would happen down here, x to the 5th, x squared, 1, 2, 3, 4, 5, and then 1, 2, 1, 2, 3, 4, 5, 6, 7. There's 7 x's, it's x to the 7th power. So that's the product rule. The quotient rule is very simple, or similar, and simple. Quotient rule says if you're dividing two bases that are the same. Okay? You're going to keep the base, and you're now going to subtract the exponents. So what does that look like? Again, the bases have to be the same. So if I have 9 to the 6th over 9 to the 4th, again, you're dividing two bases that are the same. They're both 9. So your answer is going to be the base and your exponent subtracted. You're always subtracting the numerator by the denominator. Okay, you're always subtracting the numerator by the denominator. And this becomes 9 squared. Now, why does this work? Well, let's see. If I have 9 to the 6th, that means 9 times 9 times 9 times 9 times 9 times 9 over 9 to the 4th. What happens in this case? Well, a lot of things are going to end up canceling out. For example, these two 9s cancel each other out. That's 9 over 9. 9 over 9, 9 over 9, and 9 over 9. Guess what you're left with? 9 times 9, which is 9 squared. And again, the same thing happens with variables. Okay? If I have x to the 8th over x to the 3rd, 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3. This cancels out with this one. This cancels out with this one. This cancels out with this one. And we're now left with 1, 2, 3, 4, 5 x's. Okay? Would have been the same thing as me just subtracting 8 by 3 and just keeping the base. And that's the quotient rule. Now the zero exponent rule. I want you to read this aloud with me. Okay? This is very important. Any base except 0 raised to the 0 power is equal to 1. Meaning anything raised to the 0 power is 1. Okay? Anything raised to the 0 power is 1. 5 raised to the 0 power is 1. X raised to the 0 power is 1. 3 raised to the 0 power is 1. A million raised to the 0 power is 1. Anything except for 0 raised to the 0 power is 1. Now, why is that? Well, simple example is this. Let's go back to the quotient rule, right? If I have 5 to the 5th over 5 to the 5th, what happens here? I know that I'm subtracting 5 to the 5th minus 5, which gives me 5 to the 0 power. Well, let's write this out in terms of what this means. 5 to the 5th over 5 to the 5th equals 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. Guess what happens? 5's cancel out, 5's cancel out, 5's cancel out, 5's cancel out, 5's cancel out. And 5 over 5 is just 1, so the answer to this is just 1, which is why anything to the 0 power is 1. Okay? This doesn't work for 0 because you can't divide by 0. Okay? In this case, I divided 5 to the 5th by 5 to the 5th. So it worked. Okay? Any number besides 0 will work. Even variables will work. Power rule. Okay. The power rule says that if I raise a power to another power, then I'm going to write the base and multiply the exponents. You're sitting to yourself saying, what? Huh? I get it. Let's think about what this means. Let's say I've got 5 to the third. Okay. Remember, the exponent is my power. If I raise 5 to the third to another power, meaning I'm going to have to put parentheses in there, and then add another exponent, let's say in this case I do 4. Okay, this says 5 to the third raised to the fourth power. Let's think about what it says again. It says write the base. Here's how we're getting the answer. We're going to write the base, and we're going to multiply the exponents. 3 times 4. That gives me 12. Why does that work? Well, think about it. If I've got 5 to the third, and I raise that to the fourth, if I expand this, this now becomes 5 times 5 times 5 to the fourth power. And well, this 4, this exponent of 4 applies to everything in the parentheses. So now I've got 5 to the fourth times 5 to the fourth times 5 to the fourth, right? Because it's like the distributive property. You're distributing this exponent to everything in the parentheses. And 5 to the fourth becomes 5, 5, 5, 5 times another 5 to the fourth times another 5 to the fourth. Okay? We have 3 sets of 4 5s. 1, 2, 3, 4. 1, 2, 3, 4. That makes 8. 1, 2, 3, 4. That makes 12. This is 5 to the 12th power, just like we got up here. Okay? So if I have a power raised to another power, all I'm doing is keeping my base and multiplying my exponents. The expanded power rule. Now this one says when there is a term or multiple terms in parentheses with an exponent attached outside of parentheses, then you distribute the exponent to each part of the term or terms. So again, if there's a term or multiple terms in parentheses, it's kind of like what we did earlier, with an exponent outside of the parentheses, then you're going to distribute the exponent to each part of the term or terms. So let's see what this means first. Okay? Let's see what this means first. This says 5 to the second. Sorry, this is not what this means. This means if I have 5 to the second in parentheses, that equals 5 squared. At the same time, that's one term. If I have 2 different numbers in here, let's say I had 5 times 3 squared, this now becomes 5 squared times 3 squared. Okay? Now I cannot use the product rule in this case because my bases are different. Notice my bases are 5 and 3. Okay? I cannot use the product rule in this case. Now, what I do want you to realize, is that I have the two numbers in parentheses. I don't care if I have 5 numbers in parentheses. I don't care if I have a variable in parentheses. Okay, it could look like this: x, y, z to the third. This means that I'm going to apply this 3 to every single base. Okay, all of these bases are individual. So this now becomes x to the third, y to the third, z to the third, because I'm distributing this 3 to each base. Okay? And in fact, a better word than term should just be base. Let's change that up. Okay? So again, when there is a base or multiple bases in parentheses with an exponent attached outside of the parentheses, then you distribute the exponent to each part of the base or bases. Now there is a way to actually combine the expanded power rule and the power rule. Okay, let's look at that really quick. Let's say we have parentheses, and let's stick with variables for now. Let's say I have x to the third times y to the second, and I raise that to the fourth power. Okay. Well, in this case, I have two bases, x and y. I also have them raised to a power. I have x cubed raised to the fourth power and y squared raised to the fourth power. So again, I'm going to distribute this to each one of these bases. If I look at them individually, I can separate them if I wanted to. X to the third to the fourth power. Remember, according to my power rule, that gives me x to the 3 times 4, which is x to the 12th. Okay, so remember, x to the third to the fourth. You multiply the exponents, you get x to the 12th. And then y squared to the fourth, that gives you y to the 8th. So if I combine them, I now have x to the 12th, y to the 8th. Okay. This is basically me combining the expanded power rule and the power rule together. And here's a very important exponent rule as well. They're all important. The negative exponents rule. Okay, the negative exponents rule. What this says is, if a factor in the numerator or denominator is moved across the fraction, apparently I didn't finish writing this out, or whatever. Basically, no negative exponents. We do not have negative exponents. We are not going to keep anything with a negative exponent. Here's what happens with negative exponents. Okay? What this rule was trying to say is, if I have a negative exponent, I need to change it to a positive. How in the world do I do that? If I raise something to the negative power, I'm going to get the reciprocal of the base raised to the positive power. Okay? So again, this was also going to be in fancier terms than I wanted it to be. If you have a negative exponent, get the reciprocal, oops, that's not how you spell reciprocal. Get the reciprocal of the base and make the exponent positive. Okay, so here's another example, 5x to the negative 3. I'm going to get the reciprocal of the base. X is the same, or the reciprocal of x is 1 over x. And instead of it being negative 3, I'm going to change the exponent to positive 3. Why does this work? Well, let's think about it. Let's go back to the quotient rule. Okay, remember in the quotient rule, we were told that if I have the same bases, let's go with 5 squared over 5 to the third. Let's expand this. 5 squared is the same thing as 5 times 5. 5 to the third is 5 times 5 times 5. Okay? Well, what happens with the quotient rule? If I have the quotient rule, it says to keep my base and subtract the exponent of the numerator by the exponent of the denominator. This gives me 5 to the negative 1. Well, I rewrote it up here as 5 squared over 5 to the third, except now I wrote it out in expanded form. And instead of it being 5 squared, it says 5 times 5, which is exactly the same, over 5 cubed, which is 5 times 5 times 5. Watch what happens. These 5's cancel out. These 5's cancel out. 5 over 5 is 1. So I am now left with 1 over 5. Which means that 5 to the negative first has to equal 1/5. And this works in every case. Okay? This works in every case. Let's do another one. Let's say that I have 2 to the third over 2 to the 10th. Okay? According to the quotient rule, this gives me 2 to the 3 minus 10th power, which gives me 2 to the negative 7th. Okay? Again, quotient rule says keep the base, subtract the exponent of the numerator by the exponent of the denominator. Well, if I write it in expanded form, 2 to the third over 2 to the 10th, 2 to the third is 2 times 2 times 2, 2 to the 10th is 2 times 2 times 2 times 2 times 2 times 2 times 2. Is that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and again, 2 over 2 gives me 1, 2 over 2 gives me 1, 2 over 2 gives me 1, which means my numerator is 1, and I've got 1, 2, 3, 4, 5, 6, 7 2's left, so my answer is 1 over 2 to the 7th power. Again, that means that 2 to the negative 7th is equal to the reciprocal of my base raised to the positive power. So if it was 2 to the negative 7th, the reciprocal of 2 is 1/2. And instead of it being negative 7 attached to the 2, I'm going to attach a positive 7. Okay? So this is what I really want you to understand. Now, I just told you what the rules are. I showed you why each one works. If you have further questions or need to rewatch the video, please rewatch the video. Pause, really look at the work, This can be a little bit confusing if you don't really follow along with what's going on, okay? But I'm more than happy to explain it to you again if it is unclear. Alrighty, thank you.